Hi, I'm Shanika Center. I'm the Virtual Content Specialist for Middle School Science for English Language Learners and Multilingual Learners. This is the third video for the lessons of week of June 14th, and this video is going to help students use the oscilloscope that they need to investigate for Unit 5, Day 22. Students are going to explore how waves travel through different matter using a oscilloscope. Hi, I'm Shanika Center. I'm the Virtual Content Specialist for Middle School Science for English Language Learners and Multilingual Learners. Today we are going to use an electronic or virtual oscilloscope to help us explore how sound can travel through different matter. This is going to help you complete the lesson objective for Unit 5, Day 22. Before we get started, let's review some vocabulary. Amplitude is the distance between the starting height and highest or lowest point of a wave. So the starting point is this green line, and the amplitude is the space between the highest point and this time that the wave touches through the starting point. So in this lesson, you are going to have to in this lesson, you're going to observe 3 different components of the waves that you're creating. So you're going to have to create different amplitudes, different frequencies, and different wavelengths. Before we get to the specifics of what you're going to have to do using the oscilloscope, let's review some of these vocabulary words. So amplitude is the distance between the starting height and highest or lowest point of a wave. So the starting point is the green line, and the height is the tallest, and the lowest point is the bottom. So you're measuring the distance between the starting point and the highest or the lowest point of the wave. Frequency is the number of full wavelengths that pass through a certain point on a given time. So the starting point could be 0, and then for 10 seconds, we're looking at how many times the waves are passing through. High frequency means there's a lot of waves. Low frequency means there's not a lot of waves. Wavelength is the distance between identical points on consecutive waves. So this top point is the point that we're measuring from, or measuring the distance between, and we're seeing the distance between this first wavelength's highest point and the second wavelength's highest point. So as we go through as we use the oscilloscope, we're going to track these 3 components: the amplitude, the frequency, and the wavelength. So let's get started using the oscilloscope. When you click the link, you're going to scroll down to this oscilloscope down here. So as you can see, as I talk, waves start to form. If I talk really quietly, the wavelengths are not going to be as big. If I talk really loud, the wavelengths look crazy. Oh. As you can see, this oscilloscope is responding to my voice. As I speak, different waves are forming. So what you're going to do is play around with your voice and see how that affects the oscilloscope. So what happens if I talk really slowly? What happens if I talk slowly? What happens if I talk really quickly? Play around with the oscilloscope to see what you can do to it. There's also a feature that allows you to freeze your wave. So if you're talking and you want to see what your wave looks like, click this button and it will freeze it. So that's what the wave looked like when I was talking. Take some time and play around with this. Then we're going to get into the lesson assignment. The first thing we want to figure out how to do is create a wave with a high amplitude. So if you remember, amplitude is the space between the highest or lowest point. So in my mind, I want my wave to look like this. So let's see what type of voice I'm going to need to do to make that wave. So I'm going to do unfreeze. And then I'm going to talk really loudly and see if that works. That's okay, but I think we can do a little bit better. So I'm going to see. Oh, that seemed like it did it. So as I raised my voice's pitch, right, I made my voice really high, the amplitude of my waves changed. So now, using a high voice, I have amplitude that's probably about, I would guess, 1 centimeter in length. So I would go back to my chart, and you're going to go to the scribble function, and then you're going to draw what the wave looks like. So my wave looks like this. And then I'm going to type in this box, what did I do to make this wave? So I spoke in a very high voice. My voice isn't that high, so you may be able to get your wave to have much deeper amplitude or much higher amplitude. Now I'm going to go through low amplitude. So I want you to figure this out by yourself. What do you have to do to make your amplitude low? If we had to speak in a high voice for high amplitude, what do you think we need to do for low amplitude? Once you're finished, we're going to move on to frequency. So in this case, we're going to be trying to create a wave with high frequency and low frequency. So we're going to go back to the oscilloscope, unfreeze the input, and then we're going to play around with our voice or sound and see what we can make. So we want high frequency, so many waves. So high, Ooh, that did it. So I had to whistle in order to create a high frequency wave. So I'm going to go back to the slides presentation, click the scribble function, and then draw what my wave looks like. Doesn't have to be perfect, but as long as you know what you're drawing. And then record, what did you have to do to make this wave? I had to whistle. You're going to try to do the low frequency by yourself. When you're finished, let's move on to wavelength. For wavelength, we're going to try to create a wave with a long wavelength and a short wavelength. So let's go back to our oscilloscope, unfreeze, and then we're going to play around with our voice like we've been doing to see what we can do to make a wave with a long wavelength and a wave with a short wavelength. So I think I'm going to have to hold my sounds out really long. Let's see. Oh, there we go. That one looks pretty good. So this is a wave with a long wavelength. So you can see if we look at the tops, the points between the tops are very long, or the distance between the tops is very long. So it's about, let's see, 1, 2, 3, I would say centimeters between. So you can play around to see if you can get a longer wavelength, but I'll show you or remind you how to document it. Click the scribble and then draw your wavelength. So to get that wavelength, I had to hum slowly. And now you're going to try to figure out how to create a short wavelength. Feel free to play around with your oscilloscope for as long as you want and see what kind of things you what kind of waves you can create with your voice. If you have any questions, feel free to reach out to your teacher.